Hello, here we are with the 2010 PAT. So 2 hours as usual, split into 2 bits with equal weight. So 2 lots of 50 marks here. No calculators or formula sheets or anything else throughout. Exact answers in the first part, so that's going to be the maths I would expect. And then 2 significant figures for the rest. We've still got 10 meters per second squared for G. So yes, lo and behold, it is maths to begin with. So let's see how we get on with these. Solve sine 3x equals root 3 cos 3x for x in the range 0 to pi inclusive. So we've got tan 3x equals root 3, but we're going to be able to triple the range here if we've got 3x. So we want to solve this up to 3 pi, and then we can divide everything down by 3 to get into the range 0 to pi. So root 3 means pi by 3 is one solution. So 3x is going to be pi over 3, and then it goes up in pi's, doesn't it, with tan. So we'll have that, and then we'll have that. And then we're going to have to divide all of those to get pi over 9, 4 pi over 9, and 7 pi over 9. So that's a standard exam type question. Solve cos squared x minus sine x plus 1 equals 0, all in the same range. All right, so we have to keep the thing that isn't squared unchanged because there's not much we can do about that. So we've got a 1 minus sine squared now for this. So let's make the sine squared positive. So we'll have sine squared x plus sine x. And then we're going to have 1 minus, so minus 2 is equal to 0. Sine x, what we got, plus 2 sine x minus 1 equals 0. Well, we can't have anything from this because you can't have sine x being minus 2. So we've got sine of x equals 1, which means that x equals pi over 2. That's the only solution we're going to have in this range. So standard starter, that was. Question 2, the equation of the larger circle is that. Find the equation of the smaller circle. Right, so if we've got a centre here at 1, 1, the centre of the smaller circle is going to have to be at 1.5, 1.5. So we know we've got that bit. So we're going to have x minus 3 over 2 squared plus, that's going to be a plus, I was starting to write a y. Y minus 3 over 2 squared, and the radius is going to be a quarter. The radius is going to be a half of what it was before, so a quarter when we square it. So equals a quarter. Right, that was a gimme of a question. 4 marks for that. That is insane. But still can't complain. Right, so that's that one. Question 3, show that x equals minus 1 is a root for this. So if we put minus 1 into it, then we're going to get 0, hopefully. So we've got minus 1 plus 2 plus 5 minus 6 equals 0. So that's good. So we're going to have x plus 1 then is going to be one of our factors. So we're going to have an x squared to get an x cubed. We're going to have a minus 6 in order to get a minus 6. And then we've got 1x squared. So we're going to have a x in the middle for 2x squared. So that's all good. Factorize that again. X, was it going to be plus 3 minus 2 equals 0. So we've got x equals minus 1 minus 3 or 2. 5 marks for that one. I mean, they're throwing out marks like confetti at the moment. Question 4, find the equation of the line passing through those points in the xy plane. So the gradient is equal to, well, change in y over change in x, so up 2, down 1, so minus 2. So we've got y minus 3 equals minus 2, x minus 2. Yeah, I mean, that's it really, you don't really need much else, but let's change it around. So y equals, we've got a minus 2x, 7 minus 2x, another 4 marks. Wowzers. Question 5, find the area of the shaded region of the circle in the figure below as a function of radius r. Right, so it's halfway up on that. So we're going to need some triangles. We're going to need to do a sector minus a triangle on this. Well, we can just double it up really, can't we? So if we've got an r there and an r over 2 there, so that must be 60 degrees. So we've got a third of the circle is this. So that's pi r squared over 3. And then we need to take off this, which is the, well, we can turn that into a rectangle. I suppose, couldn't we? Yeah, we could do that as a rectangle. Anyway, we take off. So we've got r over 2 at the bottom. And our height is going to be r sine 60. So we've got r over 2 times r root 3 over 2. So that is r squared pi over 3 minus, well, we got root 3 over 4. Okay, these are so far so no trouble. A rectangle is formed by bending a length of wire of length L around 4 pegs. Calculate the area of the largest rectangle which can be formed this way as a function of L. This is very similar to a question that came up in a previous PAT, but they did it with a, oh yeah, it was an isosceles triangle of fixed perimeter. And it then came out as being an equilateral triangle. And I remember going through this discussion thinking, well, yeah, we can talk about, say we've got one extreme where you've got a rectangle like that, another extreme where you've got a rectangle which is the same but flipped on the side. So we're moving these pegs around. As you move towards things which are more square-like, the area is getting bigger and bigger until you hit a square in the middle. This is going to be, through symmetry, our maximum that we're going to have. So just from a symmetry argument, we know that we're going to get each side is going to be L over 4. So we're going to end up with L squared over 16 is going to be our maximum area. So what if we actually wanted to do that as, actually working something out? So say we had X versus Y as our area, so as our rectangle. So we'd have 2x plus 2y is our L, our length of wire. A is equal to x times y. So let's get rid of the y, so we can just have A varying with x, because L is a constant, so that's going to be fine. So y is, what is y going to be? Y is, well, L minus 2x over 2. So L over 2 minus x, and we need to multiply all of that by x. So we've got that Lx over 2 minus x squared. So we can do dA dx, which is going to be equal to L over 2 minus 2x. We need that to be 0. So that equals 0 when, and we can see now, x equals L over 4. So we end up in the same place. But this has got a much easier symmetry argument than the one that we had with the isosceles triangle. I think that might have been 2008 or maybe 2009 paper. I think 2008. I can't remember. I've only recently gone through that one. So you can, if you're interested, you can always look on an earlier video. Question 7 is our standard log question. So what power do we have to raise 3 to get 9? 2. You get 2 marks for doing that. Jeez. Simplify this. So let's get everything here into log 2s then. So we've got 2 log 2. Then we're adding on 4 log 2. And then we're taking off log 2. So we've got 5 log 2. Another 2 marks. Question 8, calculate this, 16.1 squared. So we're going to have 16 squared, which is 256. We're going to have 0.1 squared, which is 0.01. And we're going to have 2 lots of 1.6, which is 3.2. So what is that? 259.21. 259.21. Calculate 10.11 times 3.2. So 3 lots of 10.11 is 30.33, and then we've got a fifth of all of this, so we need to add on 2 for point, and then a fifth of that is 0.22. So that is equal to 32.352. Fairly straightforward mathematics there. The first, fourth and seventh terms of an arithmetic progression are given by those things. Find x and the common difference. Right, so we've got x cubed is equal to a. That's the first term. Then what was it? The fourth term is, so x is a plus 3d. And then the seventh term, x squared, is a plus 6d. So we can't have either of those. So we got 3d is equal to 3d, that's equal to x minus a, which is equal to x minus x cubed. Okay, and that is also going to be equal to, what else do I need to do with this? Yeah, let's say, oh, we can just subtract again. Let's subtract this one from this one, and you're going to get the same. So yeah, x squared minus x is equal to the same thing, 3d, x minus x squared. Yeah, we're just subtracting one from the other, so we can take the first one away from the second one and the second one away from the third one. We end up with the same thing. So we've got x cubed plus x squared minus 2x equals 0. Divide by x because x isn't 0, so we're quite able to do that. And then solve this, x plus 2, x minus 1 equals 0. So find x and the common difference of the progression. X equals minus 2 or 1. Okay, so D would be in these cases then. So let's just check all this works out. Oh, x can't be 1. So we can't have that. It says here it's not equal to 1. Right, I was wondering why we were getting multiple answers. So if x is minus 2, then a is going to be equal to minus 8, which means that minus 2 equals minus 8 plus 3d, so d is equal to 2. Let's just double check all of that. That would give 4 equals minus 8 plus 12. We put it into the third one, so yeah, that's good. So we got x is minus 2, d equals 2. Right, that was fine. What are we on to now? We got the dice one. We always like the dice one. These are always pretty quick. In a game of dice, a player initially throws a single die, receives the number of points shown. If it's a 6, he then throws it again, adds the number on, calculate the probability, he will gain an even number of points. Okay, so even number of points. So we're going to get, for the first roll, so you get 1, 2, 3, 4, or 5. And then if you get a 6, that means we're going off again. So first of all, we've got a 1 in 6 and a 1 in 6 there. So they're always going to be hanging around because you don't re-roll. And then if we get this one here for a 6 being rolled, we have a 1 in 6 chance, which then comes out the 6 more rolls, of which we've got half a chance of that. So that's going to be multiplied by a half to give a 12th. So we're going to have a 6th, a 6th, and a 12th, which means we've got 5 over 12 in total. That's good. Question 11. Sketch the curves y equals x squared and x equals y squared. Label the points of intersection and calculate the area between the two curves. Okay, it should be straightforward. I would have thought they don't look difficult things to sketch. So particularly y equals x squared. We're happy with that. This is just reflected. We just swapped over the x's and y's. So you can either think of it as we're just rotating the axes. We're putting y on the x-axis and x on the y-axis, for want of a better term. So we're drawing our parabola going that way round. Or it's the reflection of the first curve in the line y equals x, because of course that's what you do when you inverse these things. So that's x equals y squared. So because it's that straight flip over, it has to intersect at where y is going to be equal to x. It has to be at 1, 1. We don't have any other place it can intersect. So that makes things a lot easier. Calculate the area between the curves. So the area is going to be the integral from 0 to 1 of which one? The top one. So x to the half, because we want to integrate by the same thing. So let's make that y equals x to the half. And then we need to take off the integral over the same range of x squared, dx. So that is going to be 2/3 x to the 3 over 2 minus 1/3 of x cubed from 0 to 1. So the 0 won't matter because everything's got x's in it. So we're going to have 2/3 minus 1/3, which equals 1/3. So another straightforward one. And that's it for that section. So that was 11 very quick questions. I think out of the papers so far that I've been through, that is the easiest set of maths questions. These are very similar to standard A-level questions. So yeah, that is a nice bunch all in all. So yeah, good stuff. I'll leave that there. Come back to the next bit in the following video.